Myself, Ketan M. Patel, Mahatma Gandhi Institute, Technical Education Research Center, Navsari, Engineering Department. Subject name is Testing and Commissioning of Electrical Equipments. Fourth year, 8th semester. Chapter number 1, Testing of Transformer, Plant and Equipment. Okay. Today's syllabus content is checking of transformer oil method and qualities of good transformer oil. Second is impulse testing method, and third one is vector group of three-phase transformer. Now, first is checking of transformer oil method and qualities of good transformer oil. The moisture and dielectric strength are measured in checking of transformer oil methods. If necessary, the oils will be filtered. The fresh dielectric oil has pale yellow clear color. A dark and brown color or cloudy appearance indicate the deterioration. Impurities have a bad effect on the properties of the oil. Because of oil have some good properties. The dielectric oil should never contain suspended particles like water soluble acids and bases, active sulfur of colloided carbon. These impurities accelerate deterioration of the insulating properties of the dielectric oil, resulting in internal flashover. The moisture and dielectric strength are measured in oil. If necessary, the oil should be filtered. The fresh dielectric oil has pale clear yellow color. The oil sample is taken in a standard oil test cell. Its rating is 82 into 60 mm cross section area into 100 mm high. Electrodes are polished brass spheres 12.7 mm diameter mounted in horizontally. The gap spacing is 4 mm plus or minus 0.02 mm. Dielectric strength of oil is very important. A sample of insulating oil is taken from the bottom of the circuit breaker tank. Dark and brown clouds indicate the deterioration. Oil in good condition has always pale yellow uniform color. It is tested by means of portable oil testing set, which consists of auto transformer, voltmeter, tripping device, etc. Voltage can be gradually increased. Oil in good condition should withstand 45 kV RMS for 1 minute in a standard oil testing cup with 4 mm gap between electrodes. Okay. A gap of 2.5 mm should have breakdown value above 45 kV. The dielectric oil should never contain any suspended particles, water soluble acids, bases, and active sulfur of colloided carbon. The impurities accelerated deterioration of the insulating properties of the dielectric oil, resulting in internal flashover. The dust particle, carbon particle, and sludge in the oil, which is suspended from in oil, gathers along the conductor and insulated surfaces in presence of electrical field. Thereby, a thin conducting layer is formed gradually along the surface of internal insulation during service. The flashover can occur along the surface of the insulation or tank due to cracking. Dust and other particles are removed by means of filters in the oil filtering unit. Moisture in oil lowers the dielectric strength, thereby causing internal flashover. Moisture is introduced in the transformer through defective seals. Sometimes oil filled in the transformer may itself have higher moisture content. Viscosity indicates fluidity. Oil with low viscosity has more fluidity and give better cooling, shorter opening time. At lower combined temperature, the viscosity sharply rises and the speed of oil circulation reduces. Hence, viscosity should be measured at various temperature and the characteristics should be plotted. Higher flash point like 145 degrees Celsius is preferred. Flash point indicates tendency to accelerate. For flash point lower than 135 degrees Celsius, the oil tends to evaporate rapidly. Thereby the viscosity rises and total volume of oil reduces. Okay. Now, impulse testing method. Impulse voltage test and standard impulse wave. This is a type test for all indoor and outdoor transformers. This test is carried out as follows. Standard impulse wave, specified amplitude is applied 2 times in succession. Okay. Here, this is a HV type transformer. Okay. This is a rectifier. This is an impulse generator. Okay. This is a spear gap. Okay. This is a rod gap. This is a voltage divider circuit. Okay. This is a CRO, and this is a test object. Okay. And this is also CRO to measure the value of impulse wave. So, if flashover or puncture of insulator does not occur, the transformer is considered to have passed the test. If punctures occur or flashover occur, the transformer is considered to have failed the test. During the test, one wave should be applied with the reversal of polarity. Test voltage is applied to each winding. Okay. Basically, the HV transformer gives the HV voltage, rectifier will rectify the voltage. Okay, this is the impulse generator. This is the rod gap. Rod gap means it's operate first and check the breakdown voltage. Then after, this is a spear gap. This spear gap is calibration and measurement purpose of high voltages. Okay. Then CRO means peak value and wave shape are recorded by the use of CRO. Okay, and this is a test object. Here it is a transformer. Okay, like any motor, any circuit breaker, any electrical equipment will measure in this test object. Okay. The impulse voltage wave is generated in one impulse voltage generator. Okay. During the test, one terminal of the impulse generator is connected to the terminal of the transformer. Okay. Other terminal of winding under test frame windings are earth. Okay. The peak value and wave shape of the test voltage is recorded by means of CRO. Okay. Cathode ray oscillograph. With a calibrated voltage divider is used to reduce the voltage for measurement. Sphere gap are used for calibration purpose. Impulse voltage is characterized by polarity, peak value, virtual front T1, virtual half time T2, virtual time chopping TC. Chopped wave represent condition created by spark over of protective gap across insulator. Standard lighting impulse is a full impulse having a front time 1.2 microsecond and time to half value of 50 microsecond. It is described as 1.2 divided by 50 impulse. Standard switching impulse wave is characterized by prolonged wave front and wave tail. The typical switching impulse wave has front time of the order of the 250 microsecond and half time of 2500 microsecond. The permissible deviations in the crest value is of the order of 4 to 12%. The switching impulse wave has been specified for high voltage transformers rated above 220 kV type transformer. Now, impulse generator. In impulse test, impulse voltage wave having a steep wave front and flat wave tails and high amplitude are usually applied to gold marked circuit. Capacitor C1, C2 etc. are charged by the rectifier to certain voltage. When the gap S is triggered by means of spark, the capacitors C1, C2 up to C10, etc. are discharged to the series gap S1, S2 to Sn, etc. And the impulse wave is applied to the apparatus under test. The total DC voltage is sum of voltage of capacitors. Now, spear gap. Spear gaps are used for measurement of high voltage, such as peak value of power frequency alternating voltage, impulse voltage waves, direct voltage. Okay. Now, the procedures consist of establishing a relation between high voltage as measured by the spear gap and indicating voltmeter and oscillograph or other device connected for voltage measurement. Under standard test conditions, the voltage measured by spear gap can be derived from the spacing. It means from the known diameter of sphere, known test conditions, and known spacing of gaps, the peak value of disruptive discharge voltage can be derived from the standard table. From this value, the other measuring instruments can be calibrated. Now, standard spear gap is peak value measuring device constructed and arranged according to rules specified by the standards, some of which are given here. Before conducting a test, the standards pertaining to HV testing techniques and spear gap should be truly studied. The spear gap consists of two metal spheres of equal diameter, like capital D, which their shanks operating here, insulating support, supporting frames, leads up to the point at which the voltage is to be measured. The standard values of diameter capital D recommended by IEC specification. IEC means International Electrotechnical Commissions. Specifications are following. Capital T equal to 2, 5, 6.25, 10, 12.5, 15, 25, 50, 75, 100, 1 and 150, 200, and unit is centimeter. Okay, so there are 12 standard diameter capital D, okay, recommended by IEC specification. Now, one sphere is preferably connected directly to earth and the frame of the transformer. The resistance connected in this circuit should be of low value. The other spheres is connected to winding under test and lead coming from HV transformer or impulse generator. Now, direct and alternating voltage. The voltage with a low magnitude is applied so that the transient switching surge voltage should not cause disruptive discharge. The voltage is increased gradually so that the voltage at which the disruptive discharge occurs can be read correctly on low voltage indications. Alternatively, a constant voltage is applied across the gap, and spacing between the spheres slowly reduced until disruptive discharge occurs. The final measurement should be the mean of the three successive readings, aggregating within 3%. In impulse voltage, impulse are obtained from impulse generator. The interval between applied till 50% probability of disruptive discharge is obtained. They obtain 50% probability. Final readings is obtained by interpolation between the readings obtained with either two gaps or two voltage settings. The reading should be such that in one case out of 6 applications of voltage, 2 or less discharge occur. In the second case, out of 6 applied voltage or more discharge occur. An indicating voltmeter is connected on LT side of high voltage testing transformer. This voltmeter is calibrated by means of spear gap connected on HT side. Once the voltmeter is calibrated, the volt of LT side can be measured by the sum voltmeter and the voltage and HT side be obtained on multiplying with turns ratio. In this method, capacitor potential divider or resistance divider is connected across the HT winding of high voltage transformer. The potential divider consists of several air capacitors in series. The voltage across one capacitor is a definite function of the total voltage. The smaller voltage is measured by means of electrostatic voltmeter. Okay. So this is a impulse testing method. Now this is a vector group of three-phase transformer. In three-phase transformer, polarity alone is insufficient to represent the relation between HV and LV windings. In addition to terminal markings on HV sides and LV sides, vector diagrams are required to show the angular displacement between HV and LV winding. Here it is HV type vector group, okay, and this is LV type vector group. This is a 0 degree phase displacement, 180 degree, minus 30 degree, and plus 30 degree. Okay, and this is a phasor group. Okay, and this is a symbol of pi by 0, dt 0, dz 0, pi by 6, dt 6, dz 6, dy 1, yd 1, yz 1, dy 11, yd 11, yz 11. Okay, and this is HV and LV type phasor diagram. And this is a winding connections diagram. Okay, and different terminals, HV sides capital A1, B1, C1, A2, B2, C2. Okay, and in LV side small a, B, C, small a, B, C. Okay. The angular difference between vector representing the voltage indeed between HV and LV terminals having the same marking letters and the corresponding neutral point, like a real or imaginary, expressed with reference to HV side, is termed as phase displacement of the transformer. Here this is 0 degree. Okay, so group 1, this is a group 1. 180 degree is group 2, and this is a third group is minus 30 degree, and its clock hour is 1. In group number 4 plus 30 degree, clock hour is 11. Okay, so 11, this is 6. This group number 1 is clock hour is 0, and group number 2 clock 180 degree, clock hour is 6. Even under normal conditions, the line to line voltage on HV side are displaced from corresponding voltage on LV side. Also, line to neutral voltage on HV side are displaced from corresponding voltage on LV sides. This displacement depends upon transformer connections like a star, delta, etc. Indian Standard 2026 to 1972 gives 4 vector group of standard connections. These whole groups are explained like a terminal marking on HV sides is A, capital B, and capital C, and capital N. On other side, terminal markings on LV side is small a, small b, and small c. Each winding has 2 subscripts, like 1, 2. As example, capital A in subscript capital 1, then capital A subscripts 2. Okay, so A1, A2 for HV winding, and small a1, small a2 for LV windings. Okay, this is the connections diagram. Okay, star, or here it is star star. Okay, so star and star connections. Here is a delta delta, so delta connections. Okay, A1, B2, okay, B1, C2, and C1, A2. Okay, so this is a delta type connections diagram. This is a delta and this is zigzag. Okay, so connection diagram is delta and zigzag. Here it is 2 windings. Okay, so next is 180 degree. This is a star. Okay, this is also star. So this is a star connections winding diagram. This is delta delta. This is a delta zigzag. Okay, so this is a connection diagram of delta delta and delta zigzag. And after also delta star, star delta, star and zigzag, delta and star, star and delta, okay, star and zigzag. So transformers are classified in 4 vector groups 1, 2 and 3 and 4 depending upon phase displacement. Here in group number 1 phase displacement is 0 and connections is y0 means star star 0, capital star small y 0 means star star 0, dd 0, dz 0. In group number 2 180 degree. In 180 degree there are star star 6, delta delta 6, d delta zigzag 6. In group number 3 30 degree lagging, okay, 30 degree means 30 degree lagging, dy1 and means delta star 1, star delta 1 and star zigzag 1. And after fourth group is 30 degree leading plus 30 degree. So delta star 11, star delta 11 and star zigzag 11. Okay, so the phase displacement is indicated by the angle in terms of clock phase. The HV vector being at 12 o'clock like 0 and the corresponding LV vector at 4 hand numbers. Thus phase displacement 0 equal to 0, phase displacement 180 degree is 6, phase displacement 30 degree lagging is 1 and phase displacement 30 degree leading is 11. Now letter Y, capital Y represent the star connected to HV sides. Letter small y represents star connected is LV side, capital LV side. Now letter capital D represents star connected HV sides. Now letter small d represents star connected LV sides and capital Z represent star connected for zigzag. Okay, so capital YD is HV sides, small y and d is LV sides and zigzag is unit is capital letter Z. Thus the symbol of star star 0 represent a star star winding with 0 degree displacement. Okay. Now summary of this whole 3 phase connections vector group of transformer. First is star star, okay, then delta delta, then star delta and then finally interconnected star star connections. First star star or YY0 or YY6. Its salient aspects first is economical for small HV transformer. Second is possibility to provide neutral connections. Third one is no triplet currents flow and neutral voltage may oscillate and triplet voltage may be high in cell type units. Its third harmonic currents and voltage circulate in the delta. Second one is delta delta or DD0 or DD6. Its salient aspects is first is suitable for large HV transformer. Next is large load unbalance can be tolerated, triplet voltage are damped out. And third one is the absence of star point may be disadvantages. So in third harmonic they are not present in the line. Third harmonic current circulate in delta voltage. Next is star delta dy or yt. Its salient aspect is very common for supply networks. One star point for a neutral to serve mixed one phase and 4 phase loads. Delta winding can carry triplet current and so stabilize the star point voltages. And finally the interconnected star star connection diagram YZ1 or YZ11. Its salient aspect is reduce the triplet voltage and not sensitive to conditions of unbalanced loading, restricted to low voltage windings, sometimes used in rectifier the supply. Okay, so this is the summary of 3 phase connections of transformers. Okay, now what is the harmonic? and or causes of harmonics. Harmonics, a sinusoidal waveform of current or voltages, consists of only one frequency component called fundamental. Such a sinusoidal waveform does not contain harmonics of other frequencies. A non-sinusoidal periodic waveform can be considered to be composed of several sinusoidal waveforms of fundamental frequency and other harmonic frequency. According to the Fourier series, or non-linear sinusoidal periodic function can be expressed in terms of some several sinusoidal periodic functions. This is the non-sinusoidal waveform can be considered to be made of the following, like a first is a constant term, fundamental component having some frequency as that of the original waveform, even harmonics such as second, fourth, etc. Since and cosines terms, odd harmonics such as third, fifth, seventh, okay, or sine and cosine terms. So the frequency of nth harmonic is n times fundamental frequency. The RMS value of nth harmonic is 1/nth of RMS value of fundamental. Harmonic currents causes additional I2R loss, core loss, magnetic interference with the protective relays, and interference in communications circuit. Harmonic voltage causes increased dielectric stress, interference with communication circuits, and resonance between inductance of the transfer winding and the capacitance of the transmission line. Therefore, harmonics should be avoided. Now, causes of harmonics. Harmonics are caused by the use of high flux density in the cores of power transformers. If the core is of insufficient cross section, the core gets saturated. The operating point is on the non-linear region of VH curve, even if primary voltage is sinusoidal waveform. The secondary waveform may be non-sinusoidal because of non-linear VH curve. Harmonics are caused by the operation of thyristor control device. Effect of transformer connections on harmonics. In single-phase transformer, its core is not saturated if operating point of magnetizing current is in the line portion of behind VH curves. Harmonic are not present if core saturation, stir harmonic EMF, and third harmonic current are induced on the secondary side. Three-phase banks of three-phase transformer first is delta-delta connection, star-delta connections, and delta-star connections without neutral wire or neutral grounding. Third one is star-star connection without neutral nothing, and fourth one is star-star connections with neutral, and second is three-phase transformer units. Okay, so harmonics is also depend in three-phase connections of three-phase transformer. Okay. Thank you.